Alright, so in this lesson, we are going to cover matrix in detail. These matrices contains only a single types of the data. That's mean if it contains a numeric data, then it contains only numerical data. Otherwise, it contains only the character data, or it contains only the integer data or boolean, these data types. All right. So as you know that we can create the matrix by calling here the matrix function. So there is the matrix function. In this matrix function, it takes, do you notice there? It takes data as the input, number of rows and the number of columns. All right, so by default, the number of rows is 1 and the number of column is 1 there. And it says that by rows is false. That's mean it is going to arrange it by column. All right. So for that, I just need to do one thing there. I want to create here one vector, and this vector is going to just hold these number. All right, there. So this vector A is going to hold these values, which are 1, 2, 3, 4, 5, 6, and then I'm going to pass this into matrix. Now this vector A is converted into matrix, and then I'm going to store it into a new variable, which is actually X. All right, so this X variable is now actually a matrix. And if you notice there, it is managed by column. All right, so these are the columns. And there, do you notice there? 1 row, 2 row, 3 row, 4, 5, and there is 6 row. And then it is getting all the columns from there. And if you want to change it, all right, so if you want to change it, you can also change it. And you can say that there by rows, and then you can say it like the true. And if you do that, then it is going to manage it by rows. Sorry, it's I think the true, that's the rows. Then you need to make it false. All right. All right, so I think there is one more mistake is here that by default, its size, number of rows and the columns are 1 there. We need to change that. So there we have to make it like, let's say number of rows is 2. And thereafter, if we do this one, then notice that it is managed into 1, 2, 3, 4 and 4, 5. All right. That's mean these numbers, which is we are saying that by rows, it is running by column. That's mean by column, it is going 1, 2, 3, 4 and 5, 6. All right. And number of rows we have already set there 2. So the columns are automatically set there 3 because the total values we have there 6. So the 6 divided by 2, we are getting there 3. That's mean it is going to 3 column. All right. Thereafter, if you set it like true and then you run it, then you get that by rows is true. That's when these values are being wrapped by rows. So there you have 1, 2, 3, 4, 5, 6. This is how it is happening. But you may ask a question, let's say, if you do not have these values in multiplication of rows, then what happens? For example, let's say we make it 7 values. Now the 7 is not divisible by 2, and then see what happens. When we try to create a matrix, if these values are not divisible by 2, then you are going to get an error, something like this. It's not error, but it is actually a warning. And this warning says that the data length, this 7, is not suboptimal or multiple of number of rows. So that's the warning. And the most of the time, R does not throw any error, but it actually throw an warning, and it try to adjust whatever data you have passed there. So what it did, it actually managed it into 2 rows. Thereafter, it just recycled this particular vector. So what it did, originally we have total 7 values there, and next value, which is 8 is divisible by 2. So it is just actually there, it is adding 1 value extra, which is actually recycle. All right, so it's recycled from there. Similarly, if you try to put it 3, then you will understand that it will recycle this 1 and 2, because 7 is not divisible by 3 and only the 9 number is divisible by 3. So it should add 2 extra value there. 2 extra value will be added. Let's go ahead and run this one. Thereafter, we are going to run here this one, and it once again says that this is not divisible. So there, all right. So there, do you see there? 3, this 7 is not a multiple of 3. So 9 is a multiple of 3. So what it did there? 1, 2, 3, 4, 5, 6, 7. So these values are taken from this vector, and thereafter 1 and 2, that's the recycle. Recycle has happened there. All right, perfect. So this is how you can create a matrix, and I have also explained you the recycling function in the matrix. This is all about in this lesson. Thanks a lot for watching it. I'll see you next lesson. All right, now I'm going to show you how you can do arithmetic operation on the matrix. Let's say you have the matrix A. So I'm going to just recreate this matrix A so that I can do there the operation. So let's say you have the matrix A, and this matrix, I'm going to create it a 3 by 3 matrix. So there it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then similarly, I have here this B matrix. So in this B matrix, actually I need to create it first like this one. Otherwise, you can simply write this one. All right, so there you have this matrix. You can simply pass this vector inside the matrix, and matrix will be created automatically. And then I say there a number of rows. I'm going to just manage here 3, and by rows and by column I doesn't care about that one. All right, thereafter I just going to copy it and paste it here. Delete that, and then I'm going to put it in B, and in the B I'm going to put here the square of this one. So there I have a 4, then I have a 9, there I have here a 16, all right, 25, and then I have here 36, there we have a 49, thereafter we have here a 64, and then finally we have 81. Let's go ahead and run this one and this one. All right, thereafter we have A, then we have here a B. All right, so we have A and the B. These are the two matrices, and now we are going to do arithmetic operation on the two matrices. So before that, I should show you that how you can access these values, all right, a sub values in a matrix. You can simply write this. If you write there A1, then you are going to access this particular value. And if you write there A2, then you are going to access this value. So moreover, it is actually working column wise. All right, so it will access this one, this one, this one, this one, this one, this one, and like that. All right, 1, 2, 3, 1, 2, 3, 1, 2, 3, something like that. All right, so but this is just accessing one value, and if you are not sure which value it is going to get, then you can actually put number of column and rows. Sorry, you need to first put the number of rows and then column. So I just want to say here that 1, 2, that's mean we are going to get one row and second column, which is 4 value. All right, let's go ahead and run it, and then we get there a 4th value. Let's say I ask you to get this value, then what would you write there? You would write there B, and thereafter you will write there, this one is the 3rd row, so you will write 3, and then the second column, that is how you will get this 36 value. All right, so this is how you can get the values in your matrix. And if you want to get whole value of a particular row, you can simply do like this, A1 and comma. And if you leave it like this, it is going to get all the value which is in a first row. And if you write something like A, comma 1, then it is going to get all the value from the first column. All right, let's go ahead and do the operation. And the operation which we are going to do here, a plus 1, sorry, there if I do, let's say if I do the event a plus 1, then what is going to happen here? It is going to add 1 in each of the element in matrix A. And if you notice that the matrix A originally it was 1, 2, 3, 4, 5, 6 like this. But if I do here A plus 1, it has just simply added 1 in each of these elements there. And you can also add two matrices together, but those matrices should be the same size. Otherwise, that operation will fail there. And if you run it, then you are going to get the result like A and plus B. So these two matrices are being added together. And similarly, you can do A minus B. That means these two matrices are going to be, the B matrix is being subtracted from A matrix. All right. And the values of a matrix can be also negative. Thereafter, if you do here A divided by B, there you are going to get the A divided by B matrix. But here one thing is very interesting. If you notice here A and there B, so what do you get there? You might be wondering that, let me show you it here. You might be wondering that one thing here, 1 divided by 1, there is 1. 2 divided by 4, that is 0.5. 3 divided by 9, which is 0.3. All right. 4 divided by 16, it is 0.25. All right. And then finally, you have a 9 divided by 81, which is 0.1111. All right. So what's happening here? It is actually dividing the values element by element. All right. Perfect. So relative elements operation are being done. All right. In both matrices. And similarly, you can do here A multiplied by B. And if you do this, then A and the B. So the relative elements are being multiplied together. That means the first row and the first column of matrix A will be multiplied by first row and the first column value of matrix B, and similarly for other values. All right. So this is all about in this lesson. Thanks a lot for watching it. I will see you next lesson. All right. Now we are going to cover arrays in R. So what is the difference between array and matrix? Matrix is stored value in only the 2 dimensions, but the arrays can be stored value in multiple dimensions. That's meaning more than 2 dimensions. All right. So let's say if I say a particular matrix, a particular array, let me see that array A, something like this. If it is stored something like, let's say I say 3, 4, and 3. So it means that it creates there 3 matrix, all right, 3 rectangular matrices. So it is creating 3 rectangular matrices, and then it is arranged into a 3 dimension. And those 3 rectangular matrices will be 3 by 4 matrix, 3 by 4, 3 by 4. And then it will be arranged into a 3rd dimension. So that's the advantage of the array. That means to say that array can contain matrix. All right. Array can contain the matrices and matrix there. So let's go ahead and start some operation on the array. But before that, we need to create an array. So there, let's say I have A, and this is our kind of a global variable. We have been working with A, B, C, and X, Y, and G. All right, so you can choose any of the variable name, and later in this course, we will be choosing a different variable names depending on the course, project name, and other things. So as of now, we are just going to see with the simple variable names like A, B, C, X, Y, and G. All right, so there I have A, and then I'm going to create here with a column, with the vector. And in the vector, I have 1, 2, and then 3. And thereafter, I have here another vector, and there I have here 4, 5, and 6. All right, so these are the 2 vectors I have currently, A, B, C, A and B vector. Thereafter, I can simply do like this array, and then I need to put these two vector in another vector. So that vector is going to be A comma B. So it's like this. And thereafter, if you run it, then you will be getting a result something like this. I think I have not used this one. Let me first run this one, and then this. So you will get something like this. And let's say if I say here, G is equal to like this. And if you notice this G, and if you notice the value of that G is here, and it says that the value is adjusted from 1 to 6, and then it is one dimension. All right. Moreover, it is not very much clear that what is going to be a size of this particular array. All right. So to understand the size, we are going to give the size of the array, all right, separately. So the size of this array I'm going to give separately. Like, let's say I want to manage these in I want to manage this into 2 dimension, 2 by 3 and 1. All right, let's say this one. So it's like this one. Now it is going to do. And what do you see there? You see there, it's going to be 1 to 2, there is 1 to 3, and there is 1. All right, so it's like 3 dimension is there. 1 dimension, 2 dimension, and 3 dimension. So this dimension is saying that which is corresponding to row there. All right, so the number of rows are there, 2 rows, 3 columns, and there is only 1 dimension in the third dimension. All right. Thereafter, you can do other operations on the array. All right. All right. So in the next lesson, we will look how we can name a column and array, how we can name a column and rows in array. And we will be also working with the accessing the elements of the array. All right. I'll see you next lesson. All right, so we have created these simple array. Now we can make it a little more complicated. So for that, I'm just going to create here our vector A, and in the vector A, I'm going to put here 1, 2, 3. And thereafter, in a vector B, I'm going to put here the square of these 1, 2, 3. I'm going to simply get it from here. All right, so this is another vector, and this vector is a square of first vector and other strings. So the moreover, this one is having only 3 values, but this one is having total 9 values. All right. Thereafter, I'm going to create here a new array. So in a new array, what we can do that we can create here a 3 cross 3 matrix. All right. So there is 3 cross 3 matrix, and thereafter we will be managing it into another direction. All right, that's the third direction. So for that one, it's pretty much simple. We can do like this. There is the array, and in that we are going to again put another vector. So there I have A and B vector, and if we run it, we get a result something like this, and we can make it much more clear if we do like this. So it says that we have there total. This is actually 1-dimensional vector, and sorry, I need to run this one first. Run this one, and then this one. All right. So thereafter, it has total values there. Do you see there? Total number of values are present there, 12, and this array, particular array, is managed in only 1 dimension. All right. Now I'm going to convert these total 12 values in multiple dimension, and for that I'm going to create here another vector, and in that vector I'm going to pass here 3, 3, and 2. If I run it, thereafter you will notice that this G is managed into 2 dimension, and these vectors are managed as 3 by 3 vector. All right. and thereafter if you print this G, you will be getting this whole result something like this. All right, so there, do you notice a 3 cross 3, and this 3 cross 3 vector is managed into a 2 dimension. But one thing you might be wondering here is that this whole vector is not actually getting into a 3 dimension, because this 3 cross 3 is just going to manage, I mean to say that these numbers are going to manage in only one matrix, which is 3 cross 3 matrix. So what is happening for these values? So these values are being pushed into the second dimension, and thereafter we still need at least there, how much? There we need at least 6 more number. All right, means to say that you have here what you have. There you have 3 into 3 into 2, which is 18. All right, but here we have only total 12 numbers. That is actually saying that we are lacking 6 number. So that 6 number will be repeated from this array. And if you notice that these numbers are being repeated from these array, 1, 2, 3, it starts from here, and thereafter 1, 4, 9. All right, so this is repeated from there. So how we can manage that it should not be repeated? For that, we have to make sure that our this array should have total 18 digits. All right, so this one is 18 digits, and to do that, we can do like this: 1, 2, 3. Thereafter, we have 4, 5, 6, 7, 8. Sorry, 8, 8, and then 9. Now if you run this A, B, and G, and then finally this, you get the G, and now this G value is not repeating. So what is happening here? A 3 by 3 matrix is created for a vector A, and thereafter another 3 by 3 matrix is created for vector B, and then these 3 by 3 matrix has been appended on each other, and so it becomes a 3 by 3 cross 2. That's when there is a matrix, a 3 by 3, and there is another matrix which is also a 3 by 3 matrix. That's when there is total 2 matrix is there. All right, now we are going to give the name of rows and column for these matrix, and to names and the columns for these matrix we need to assign their number of rows and columns. All right, so for that I'm going to simply create here, let's say a vector, and in this vector I'm going to first say that this one is going to be, let's say, the column, and then I say here column 2, and then I say here this one is going to be a column 3. All right, so this one is column. All right, that's the calls, and calls are like columns. And then we have here a rows, and in the rows we have something like this, going to be row 1, and thereafter you have here a row 2, and then you have here a row 3. Let's go ahead and run this one and this one. Now we have columns and rows name. Once you have these one, thereafter we are going to assign these values in our G variable. But these are just the column and rows names. We also need here the matrix name. All right, so there I say here, that's, let's say, the mats. All right, so those are actually the matrices name, and in that we are going to say here this one is going to be the matrix 1, and then I have here another one is matrix 2. All right, that's mean we have here the 2 matrix. So what's happening here, because we have managed it into 2 matrix there, and there is also 3 by 3 rows and the column. So we are also going to give rows, columns, and the matrix name. Once you have given all these numbers, then we can simply recreate our array. And if you want to know the details about the array, you can simply put here a question mark, then you write there arrays. All right, so there, and you just run it. Thereafter you will get the whole documentation about the array here. All right. So once you have got this one, thereafter we need to put here the dimension names. So there I have here, these are the dimension names, and in the dimension names we are going to put it like the list name. So it takes first rows, and thereafter it takes columns, and then it takes the matrices name. And this is how you can do this. Let's go ahead and run it. And then if you run this G, you will be getting there. These are the column names, and there is the rows name. And first it is printed, it is first printed matrix 1, and thereafter it is printed matrix 2. All right. So this is how you can give the name to these matrices. And now I'm going to show you how you can now access these elements from this. Let's say if you try to do something like this, and if you try to do this like this, it's going to give you the first value of a first matrix. And total we have 18 value. So if you write there 18, it is going to give you the last value which is in the second matrix. All right. But let's say if you want to get the value, if you want to get the value matrix by matrix, then you can simply pass this. Let's say you have a 3, comma, let's say the 2, then what you are going to get here. All right, let me know. So if you run this one, it says that this is incorrect number of dimensions. So why this is incorrect number of dimension? Because our array is 2 dimension, 3 dimension, and we are just passing here the selector only for 2 dimension. All right. So the first we have row and the column and then matrix number. Let's say if I want here the third row, all column, and from the second matrix, then you run something like this. So it gets here a third row, all column of a second matrix. That is the one way to do this. Let's say if I do like this, 3, comma and comma. So it says that get the third row of all columns and all matrix. All right, there you get there matrix 1 and matrix 2 for all column and all matrix. And similarly, you can select if you want here the first matrix. So there you get the value from only first matrix. All right, perfect. So this is how you can work with the arrays, how you can name the columns of array, and how you can access the values from the array. So this is all about in this lesson. Thanks a lot for watching it. I'll see you in next lesson.